Homework 23 starts off with sketching the graph of a secant or cosecant function. The secant function is the inverse of the cosine. The cosecant function is the inverse of the sine. So what's going to happen is, if I just start with a sketch of a graph of the cosine curve, my normal cosine curve starts up, has a period of 2 pi, and has its minimum at pi, maximum here, and looks something like this. Remember, we have zeros here. Well, if I'm going to do my secant curve, for wherever I have a 0 on my cosine curve, I'm going to have something that's 1 divided by 0. So I'm going to have that asymptote there. That's that imaginary line that my graph is not going to cross. My secant curve then is going to touch the same point that it touches here, but instead of curving this way, it's going to flip it upside down and it's going to curve this way. So my secant curve is going to look something sort of like that. If I would do my sine curve, my normal sine curve starts at 0, 0, crosses at pi, also crosses at 2 pi, and has its amplitude here, going like that. So for my cosecant curve, wherever there's zeros again, I'm going to have an asymptote because I would have something divided by 0. It's the inverse or the reciprocal. And again, it's going to touch this point, but instead of going this way, it's going to go this way and this way. So, secant curve, cosecant curve. So when we are going to graph a secant or a cosecant curve, we're going to do it just like we were going to either graph the cosine curve or the sine curve, and then we're going to adjust it to the inverses. So I think about what I do when I was going to graph the sine, or this one is cosine. So for my normal cosine values, we said that we had 0, pi over 2, pi, 3 pi over 2, and 2 pi. At 0, we're normally up at the amplitude. At pi over 2, we're normally at 0. At pi, we're at negative the amplitude. At 3 pi over 2, we're normally at 0. And at 2 pi, we're normally at the positive amplitude. So I'm going to take the 1 times the amplitude, negative 1 times the amplitude, and so forth. First of all, I have to figure out my shift here. I have my 1/2 for my b value, and so I'm going to have 1/2 x equals 0, 1/2 x equals my pi over 2, 1/2 x equals pi, 1/2 x equals 3 pi over 2, and 1/2 x equals 2 pi. Just like we did when we were going to do the cosine curve, we set this equal to each of our normal values for x and solved. So to solve these, we're going to times 2 on all of them. So 0 times 2 is 0. Here 2's would cancel out, I get pi. Here I'm going to get 2 pi. Here my 2's cancel out, I get 3 pi. And here 2 pi times 2, I get 4 pi. So if I have a 1, I'm going to take 1 times my amplitude, so I'm going to have 2. If I have a 0, I'm going to have an asymptote. Here I have negative 1 times my amplitude, so negative 2. Here I have 0, so that's where I'm going to have an asymptote. And here I have a positive 1. 1 times 2 is going to give me 2. So at pi, 1, 2, 3, 4, so at pi, this would be 1 pi, I have an asymptote. At 3 pi, I also have an asymptote. Now they're going to tell me to do 3 consecutive asymptotes. I only have 2, but I can figure out where the next one is because every 1, 2, I'm going to have another asymptote. 1, 2. Here's my next asymptote then. 0, 2. I have a point. At 2 pi and negative 2, I have a point. Sometimes you have to use the plot point tool to get these on here, depending on what they have for the graph. And at 4 pi, I'm at 2. So I'm going to put the three asymptotes. I'm going to put at least 2 points, one on each side of the middle asymptote. If I've got more than 3, that's okay. I'm then going to hit the graph button. And when you hit the graph button, it's going to start putting the rest of my graph on there for me. You might even see this one over here. Oh, I drew it up a little high. Because it's going to hit at 2. And so you're going to see a graph that looks something sort of like that. They want you to have at least 3 asymptotes and at least 2 points, one on each side of that middle asymptote. You can have more points on there if you want when you draw it on Alex. So number 2, we're going to do the cosecant. The cosecant is the inverse of the sine, so you want to think about your normal starting values for the sine curve. So again, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Normally the sine curve starts at 0, ends at 0, the middle is at 0, and normally it goes up first and down second. So we have those values in there for our normal sine curve. Here we are going to set 3x equal to each of those starting x values. So 3x equals 0, 3x equals pi over 2, 3x equals pi, 3x equals 3 pi over 2, and 3x equals 2 pi. So in order to solve that, we would be dividing by 3, which since we have fractions is multiplying by 1/3. So I'm going to multiply each of these by 1/3 to solve. So here I get 0. Here I'm going to get pi over 6. Here I'm going to get pi over 3. Here the 3's cancel out, so I get pi over 2. And here I'm going to get 2 pi over 3. So wherever there's a 0, I'm going to have an asymptote. I'm going to have an asymptote here, an asymptote here, and an asymptote here. Because for the sine curve, the beginning, the middle, and the end all cross at 0. Then I'm going to take 1 times my amplitude 2/3, so it's going to go up to 2/3 first, negative 1 on my amplitude, so negative 2/3 second. So my asymptotes are at 0, at pi over 3. Pi over 3, let's see, what units are we in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 between 0 and pi, so each one is pi over 12. If I have to do pi over 3, making my equivalent fraction, 3 goes in there 4 times, so I need to do 4 pi over 12. So 1, 2, 3, 4 marks, that's where my next asymptote is. Which means 1, 2, 3, 4 marks would also be my next asymptote. 2 pi over 3. If I put it over 12, 3 goes into 12 4 times, I'd have 8 pi over 12. 1, 2, 3, 4, 5, 6, 7, 8, right? Pi over 6 is up at 2/3. This is one we'd have to use the plot point tool. That one that looks sort of like a little graph with an X, we'd have to type in the ordered pair because it's at 2/3. Pi over 6 would be 2 pi over 12. So halfway between here and here, going to be up to 2/3. We'll just estimate it, but on Alex you have to have the plot point tool put it on there. And then at pi over 2, which would be 6 pi over 12, but happens to be marked, we'd be at negative 2/3. So once we've got that, we can hit the graph button, and then Alex is going to continue on, and it would actually fill in the rest of the graph to the end, but it's going to look something sort of like that. The third one, again, we are going to do a secant curve. The secant is the inverse of the cosine, so we think about our normal values for the cosine function. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. 0, we usually go up 1. At pi over 2, we're at 0. At pi, we're down 1. At 3 pi over 2, we're at 0. And at 2 pi, we're back up 1. We have 1/2 x to equal each of our values. So 0, pi over 2, 1/2 x equals pi. Yeah, that was right. Getting ahead of myself. 1/2 x equals 3 pi over 2, and 1/2 x equals 2 pi. So in order to solve this, we would be dividing by 1/2, which is multiplying by 2. So times 2 on each of those. So 0 times 2 is 0. Here, 2's cancel out. I get pi. Pi times 2 is 2 pi. Here the 2's cancel out. I get 3 pi. And 2 pi times 2 is 4 pi. Here, I am going to go in the negative direction first. 1 times negative 2 is going to give me negative 2. Here I'm going to have an asymptote. Here, negative 1 times negative 2 means I'm going to go to positive 2. Then I'm going to have another asymptote. And then 1 times negative 2 means I'm going to go to negative 2. So I have an asymptote at pi. And I have an asymptote at 3 pi, which means, if I could draw straight, I also have an asymptote at 5 pi, right? 0, I'm at negative 2. At 2 pi, I'm at positive 2. At 4 pi, I'm at negative 2. So again, once I hit the graph button, it's going to draw in my secant curve for me.